Okay, so today's first Thevenin video, I'm going to explain how to do them. So, this is a normal, regular, simple circuit. There are some rules. The first thing we need to do with Thevenin equivalent circuit is remove the load. This 200 ohm capacitor is the load. So we're going to create a Thevenin equivalent circuit. So we have to get VTH. Hold on, we got to get VTH. We have to get ZTH, and then we put back the load so we can get the voltage. This is what a Thevenin equivalent circuit looks like. This is VTH, this is ZTH, and this is the load. In this case, in this circuit, the load is a capacitor. So when we remove this load, we put it in the Thevenin equivalent circuit, and we have that here, 200 ohms. Don't forget this is AC, so it's at an angle of -90. This inductor up here is going to be at a positive 90. So once we remove the load, we have to get VTH, which is the voltage for this circuit. I said RTH, but it's actually ZTH, which is Z total within that circuit. And then within the Thevenin equivalent circuit, we're going to get the voltage across this load. So I'm going to redraw the circuit. Here we go. With the load out of there. So I have 50 volts at an angle of 10. I put back that 300 ohm. I put back the 400 inductor. So I have 300, 400 at an angle of 90. And then here's my A to B. So when I'm getting VTH, we actually have to get voltage A to B. Now we can go voltage A to be this way or voltage A to be this way. It doesn't really matter as long as you start at A and you end at B. So what do we actually have here? We have a series circuit because this is all open. So if we get the voltage here, we can just do voltage A to B. If you wanted to double check it, you can get the voltage for this 300 and check out voltage A to B here. This is going to be a positive to a negative also. Positive, negative, okay? So which means the current is going to flow this way, positive, negative, positive, negative. So what I'm going to do here is just use the voltage divider rule to get the voltage across the 400 ohm. So 50 volts at an angle of 10 times 400 ohms at an angle of 90 divided by, both of them added together, 300 ohms plus 400 ohms at an angle of 90 equals. And this is the voltage divider rule, and this will give me the voltage across this 400 ohm. So I'm simply going to stick it in my calculator. Okay, I got 50 at an angle of 10 times 400 at an angle of 90 divided by, the bottom has to be in parentheses, 300 plus 400 at an angle of 90. So the voltage across the 400 ohm is 40 volts at an angle of 46.87. Because of this third number, this 6 goes up. So the voltage across here is 40 at an angle of 46.87. So now when we go voltage A to B, the voltage is 40 at angle of 46.87. So we can go back with our Thevenin equivalent circuit and put it here. So VTH is 40 at an angle of 46.87. 87. Okay, so now we have to get ZTH. When we get ZTH, if we have a voltage, we short it. If we have a current, we open it. So we would take this voltage and short it. And you would have 300. And then we would have 490. You go back to your A and B. You can think of this as the look back method and put your I here, or you can just put a fake voltage source. If there was a voltage source here, you know you always have to work your circuit furthest in. In this case, if this was your source, you would actually have 300 in parallel with 400 at 90. And that would be ZTH. So let's go ahead and do that. It's 300 ohms in parallel with 400 ohms at an angle of 90. Remember, when you do with AC, this has to be in parentheses, otherwise you're just going to get the reciprocal of that. So I like to put everything in parentheses just for fun. 300, shift reciprocal. Remember, that just goes 1 divided by, plus, open parentheses, 400 at an angle of 90, close, shift reciprocal, equals, and then one more shift reciprocal. So, ZTH is 240 ohms at an angle of 36.87. So that's our ZTH. So now we put our ZTH here in our Thevenin equivalent circuit, and it's 240 ohms at an angle of 36.87. So now we have our Thevenin equivalent circuit. And what was our goal? Is to get the voltage across the load within the Thevenin equivalent circuit. So we're going to use the voltage divider rule. So VRL is E total, which is 40 at an angle of 46.87, times the load, 200 ohms at an angle of negative 90, divided by Z total, which is this plus this. So 240 ohms at an angle of 36.87 plus 200 ohms at an angle of negative 90. And that's our end goal. So we're going to stick that in here. We got 40 volts at an angle of 46.87 times 200 at an angle of negative 90, divided by 240 ohms at an angle of 36.87 plus 200 ohms at an angle of negative 90. So our VTH is, the voltage across this load is 40 volts at an angle of negative 26.87. And that's the answer we're looking for. We're looking for the voltage across the load within the Thevenin equivalent circuit. Okay, there's more to come.